So here's an SAT problem that I would definitely classify as a little trickier than a lot of others. Sucks up a little bit of time. Story problem as well. So we'll get into it here. Small business owner budgets $2,200 to purchase candles. The owner has to purchase a minimum of 200 candles to maintain the discounted pricing. If the owner pays $4.90 per candle to purchase small candles and $11.60 to purchase large candles, what is the maximum number of large candles, so the most large candles that the owner can purchase to stay within the budget and maintain the discounted pricing? If you've worked through an Algebra 1 class before, you've likely encountered this sort of problem. It's not really a quick type of problem to solve. You have two different inequalities that come about here. You need the total amount of candles purchased to be greater than or equal to 200, right? You lose the discounted pricing if you fall below that 200 candle purchase. So the number of small candles purchased plus the number of large candles purchased has to be greater than or equal to 200. You also have a budget here. You need to stay less than or equal to $2,200 spent. So I'm going to take the total cost of my small candles, $4.90 per small candle, times the number I'm going to purchase, and I'm going to add on the cost of each large candle times the number of large candles I'm purchasing. Both of these inequalities would have to be true in order for the business owner to stay within budget and to maintain the discounted candle prices. To solve a system of linear inequalities, you are going to need to use a graph. Now, you've likely spent time in your Algebra 1 course building these graphs by hand. We do have access to Desmos on the SAT. So what I did is I went to Desmos. Now, I did have to swap out S and L for X and Y. So you'll notice I typed in my first linear inequality with X replacing S and Y replacing L. So that's the inequality that's shaded in red. So if I pick an ordered pair from this portion that's shaded in red, I am going to maintain the discounted pricing. I also graphed the budget inequality, so the prices inequality. Also had to swap out S with an X and L with a Y. So the blue shading that you see here is going to allow the business owner to stay within their budget. If you look at where the overlap is, it's within this triangular portion of the graph, right, where we are above the red line and below the blue line. If I pick an ordered pair here, 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 I am going to stay within budget and maintain the discounted pricing. So there are quite a few different answers for this system of inequalities. The answer that we are after is the maximum number of large candles the owner can purchase. So I went ahead and looked at my y-axis, right? I replaced L with y. So I see right here, if I'm at that highest y value on the y-axis, I'm not in the red section of the graph. So I moved over a little bit to the right, and I used Desmos to figure out that that intersection was 17.91, 182.09. I obviously can't purchase decimal numbers of candles, right? I have to stay with a whole number of candles being purchased for both small and large candles, both X and Y. So I thought, this value is really close to 18. This value is really close to 182. So what if I just take those values and round them off to 18 and 182? Do I maintain the discounted pricing if I purchase 18 small candles and 182 large candles? Yes, I get to exactly 200 candles purchased. Doesn't say I have to have more than 200 candles purchased. It says I have to have that being the minimum number. So I do maintain the discounted pricing if I purchase exactly 200 candles. Do I stay within budget? So if I purchase 18 smalls and 182 larges, I end up spending $2,199.40, which is 60 cents under budget. The most large candles you can purchase while maintaining the discounted pricing and staying within budget is 182.